presentation on section 7.1, which is the beginning of Unit 7. We're only going to be doing two sections of Unit 7, both 7.1 and 7.2, and that will be this week's focus, okay? So, and what we're going to be dealing with is something in inferential statistics, which means we're going to be taking information from a sample and then making an assumption or a prediction about the population. So in this case, we're going to take the sample given to us, and we're going to try to create some intervals where we believe the population mean will exist, okay? So what you'll notice in this first section is called the confidence intervals for the mean when the standard deviation is known, okay? So we know what so if you're looking at this problem right here, we have a sample of reading scores of 35 fifth graders with a mean of 82, and the standard deviation of the population is 15. So if we know the standard deviation of the population, this is the specific skill we're going to use to try to predict the mean, okay? Now, when you think of confidence interval, you're thinking of, man, does it just mean how confident I am in it? And that's exactly right. So you're saying with 90, like you could choose different percentages of confidence, so like 90%, 95%, or 99%, you're going to create some intervals that say like, I am 90% confident that the population mean exists within this interval. Or I am 95% confident that the population mean exists within this interval. And this is important because we obviously can't sample everybody or the entire population because it would take too much time. And so what we have to do is create these confidence intervals. And I'll explain at the end where maybe you have seen these and you weren't aware what they actually meant, but they were referring to confidence intervals. So let's dive in here. This thing can look a little complicated right at the start, but please understand, if you recognize this, please look at this, is that this is just an inequality. Inequality. I shouldn't put a line underneath it because that would mean equal to. That just means an inequality. You'll notice that on either side of these, they're the exact same formula. The only difference is this side is x minus and this side is x plus. So what we're trying to do here is create an interval, right? An interval of where we believe the population mean exists. So this is, in inequality sense, how we create an interval of where we believe the mean exists. Now, as a background story, I'm not going to dive too much into it, but this formula exists from what we have done in 6.3, which is essential mean theorem. So just realize that this is where this idea is coming from, okay? So let's dive into, the central limit theorem. I had to look that up real quick. That didn't sound right. So we're going to use the thing from 6.3, which is the central limit theorem, to create these problems. So if you want to, you can solve for mean u, and you would get these formulas, okay? So I digress. Let's dive in, and let's see what we got here. So what you're going to find is the general things we use for confidence interval for reasons unbeknownst to me is 90%, 95%, or 99%. Frequently, people use those as the main confidence intervals in their problems. You'll notice that in problem 11 here, we use 95, and then we also do the same problem with a 99% confidence interval. So, what we're going to look at is how that applies to this. Now, what I want to dive into first is this idea of this notation, this z with a subscript. That represents the margin of error. So you see this little piece of information right here in both cases. That's what we're using as the margin of error, and that's where these confidence intervals come into place. Now I'm going to briefly talk about where these numbers come from because I do think that is important for you to see big picture stuff, okay? So let's just take the 95th percentile confidence interval, and it gives us 1.96 as that margin of error. Okay, so let me talk about this in terms of what we've done in the past here with 6.1. So if I'm talking about the middle 95%, so in between here is what I want to get. What you have to understand is that, so if we have the z-scores here, we need to find what these z-scores are. Now, some people would say, well, that's 5% on this side, 5% on this side, but that would not work, right? Because that would equal 105%. So what we have to do is split the 5% on both sides of the equation. So that would result in 2.5% and 2.5%. That's where this, see this divided by 2 thing comes into play. That's why we write divided by 2. You won't have to do this because all you have to do is put in this place is this decimal. And when I get to the example problem, you'll see that big picture stuff here. So we got 2.5, 2.5. Now, if I look at this, that would mean that if I'm looking at this side of the, let me draw that again here. get rid of that arrow. If we go back to 6.1, that would mean that would be 0.9750, right? Like if I'm looking at the percentage that exists on this side, if I'm saying 2.5% this side, then that would be 0.9750 this way. So what is that z-score that exists right there? So let me bring up our trusty thing here. Let's see. If you notice, I already got it highlighted that the closest z-score to 0.9750, or exactly on the button, is 1.96. So that's where this idea, this margin of error comes from, is from our z-score, and the closest thing to, in this case, 97.5% or 0.975. Very rarely will we be asked to do that. But I just wanted to show you just where these decimals come from, and they're not just made up anywhere, okay? So let's dive in here, and let's just go through an example problem. And again, maybe this will help bring context to what I'm talking about here. So again, what we're trying to do is get a confidence interval of like, this is the interval at which I believe the population mean exists. And what level of confidence I am is based upon what the question is asking on. Or if I want to be 99% confident that the population mean exists in this area, I'm going to use this as my margin of error. Okay, so let's just look at the first part A here. And this is what we've done in the past. So find the best point estimate of the mean. Well, if I'm looking at this, I'm saying, well, the best point estimate would be just what is the mean of the sample? The mean of the sample is 82. Now, some people would say, well, that's going to be pretty close to the population mean. And that's where you would end it, right? Because you say the best point estimate of the mean would be, well, the sample mean that I got, okay? But let's say that's just not good enough, because really, in all actuality, it may not be exactly the same as the population mean from 35 of the fifth graders, right? So what we're going to do is we're going to create a confidence interval to express where we believe the population mean exists. So what I'm going to do is I'm going to rewrite this thing down here so you can follow along here. So I got the sample mean minus the margin of error times the population standard deviation divided by the square root of the number of people in the study. And then between where the population mean exists, and then it's going to be the exact same thing, just instead of a subtraction sign here, it's an addition because I'm going on either side of the population mean. And same kind of formula here. So let's put all this stuff in, and you can see how it's going to probably repeat itself a couple times here. And to speed up this process, I'm just going to kind of write this out here. So we got, I'll put the sample mean as blue. So let's see, we got 82 minus, and then this is going to be where our margin of error goes. And because I'm talking about the 95th percentile, I'm going to use 1.96. 1.96. Standard deviation of the population is 15. And then let's see, the number of fifth graders is 35. So that's where I'm going to put in the square root here. Square root 35. Okay. Ooh, that's going to bug me if I do that. Let's see here. All right. Whoop. Okay. And these are just going to stay neutral because I'm, again, creating an interval. And then I'm just going to write the exact same thing. So give me a moment here. 82 minus 196. 1.96, sorry. Parentheses. And we got 15. And then square root 35. And again, I'm getting all this information just from the problem. I chose 1.96 because I'm talking about the 95th percentile here in part B. So if I do all the math correctly, you should end up with 77. Oop, I should write it in. So if you do the math correctly here, 77.0, 87.0. So what this means in the context is I'm saying that with 95% confidence, based upon our sample that we have and the population standard deviation, that our population mean is between 77 and 87. Okay? So, and that's with 95% confidence. Okay? Now, if we do part C here, I want you to pause the video and see if you can do part C real fast, and then I'm going to write it up really quickly, hopefully here. So the only thing that changes here is that instead of using 1.96, I'll highlight that, is instead of using that, because I'm saying 99% confidence, I'm going to use 2.58. Because up here, look at here, a 99% confidence interval, use this one, 2.58. So I'm going to use the same exact stuff. And the convenient thing is that if you keep this stuff in your calculator, you can just switch that out. I apologize, I forgot to put plus here. Plus the same exact thing again, except we are changing the confidence level to 2.58. And so 15 and square root 35. And so if we do the math correctly and get everything put together, it's 75.5 and 88.5. Okay? Now, what you'll notice is which interval is larger. This is a good question with part D, and sometimes people get a little confused, like, why is it larger if I'm getting more precise? Think about it though. Like if I'm saying I'm 99% confidence, that means I would have to widen the interval a little bit more to make sure I include all the possible situations. So you'll notice that if I'm talking about 99% confidence that the population mean exists in this interval, I had to take it out 1.5 more. Okay, so this is important, that if the more you increase your confidence interval or confidence level, the bigger your interval is going to get, because you have to be confident that it's going to exist in there. All right. Now you're probably asking questions like, well, why doesn't everybody just do 99% confidence level? Well, that's a good question. Sometimes you see on political situations where they have a vote and they say, let's say the population mean voted for this, and it has the little plus or minus 0.05. That is referring to this idea of confidence intervals, of how much it could be off based upon that. So maybe you've seen that before. But anyway, I did do number 11. That kind of gets you set up for the practice problems you might see on the quiz. In the next video, I'm going to do finding the minimum sample size, or problem number 23.